Hello? I think that did it. Yeah, that did it. Perfect. And no delay as well. Like, no delay at all. Okay, that's nice. Um, Let me make sure the category is set. I really wish you could set a default category, but we're good for now. So, the cool thing, well, not really the cool thing. Um, One minor administrative thing, I just set up I just finally like bothered registering for Twitch affiliate. And the main reason I did that is if you don't have like the Twitch Turbo whatever thing, the subs disable ads fully. I tried to reduce the ads to only be 30 seconds an hour, which is the minimum. But if I do that, then you get pre-roll ads. So I left it on 3 minutes an hour, which is the minimum to not have pre-roll ads. And then the sub disables ads. Best I can do. But I also figured maybe it gives lower latency or whatever. I don't know. Anyways, hello folks. Let me make sure my chat still works. It does. And Twitch, at least when I started up the stream, we'll see if it drifts. But it's like basically zero latency today. I messed with some settings. I was on like some weird network connections. We should be good. Okay. So, here is the deal now. All right, here's the deal. We have, actually, let's just show this real quick. We have about 11,000 lines of code total here. And I'd really like to start getting towards something that is official releasable. You know, I'd like this to be close to what we can release officially. Hey, Liberty. In order to do that, it's just going to take quite a bit of time of me going through little bit by little bit. In my mind, this is one of the actually most valuable things I do, even though it is quite slow. I'll try to keep it entertaining. But I figure I will chip away at it a little bit today because I'm in a good mood to refactor some stuff. You can see I've moved some things around in here. Hey, Convert. Very nice. If you have like good test ends, we definitely need more of them, especially self-play amps. I cleaned up the top chunk of this. I'm still not entirely sure we want the Kublast wrappers like this. Right, I was gonna actually try to think about our tensor names, wasn't I? Even though naming is much more minor, it is slightly more productive for me to do it earlier. Okay, they just have tensor. Legacy C. They literally did the same thing, didn't they? ND array. Uh, so this actually does match the old Torch C, which is probably why I have it. What agent? This is just Grok. All convert. Yeah, it's well. That's the thing. They're all essentially interchangeable, except I've been enjoying this a lot just because this model is much faster. Hey, Anish. Welcome. I like this. I think that is the C99 style. I think that's a more modern thing, isn't it? Even like stupid things like this actually does matter. ID-ish, console, house. Okay. Yeah, this is like a Rust thingy. Is that useful? I mean, I'm gonna be honest, like, the main reason I don't like this is because it looks like fucking Rust. No, that's not really it. It's because then you have to change stuff from the default types, right? No, it isn't standard, to be fair. That isn't standard. Okay. Any fun update? Have you seen this? Don't blink. Solved. Okay, bad seed. Probably this is better. Really? Okay, there you go. Little bit of seed inconsistency. But we do get sub 1 second solves. 50 mil plus SPS, by the way. Buffer's fast, my guy. Gotta keep up. Hey, Convert. That's when I saw your comment. 5C branch inish is already pretty stable. I am refactoring quite a bit still, but it's mostly local changes. Breakout is... I mean, it's a simple end. We just use it as a very fast test, right? This is our agent playing it on the website. We have much more complex stuff on here as well. Lower param. No, what do you mean? Did I get lower? That's just from the sweep. What even is it? Yeah, 4x32. This is just a thing that the sweep found, man. The thing that's funny about this is still gotta be pure membound, right? This has gotta be like 0 MFU. I do wonder, do we name Collide if we just do like... I don't know what we call like the precision type. Not drop below 1.4. Still solves. Yeah, so you don't have async though, right? This is our new async trainer, man. So like decent GPU env, but then also the async trainer adds a lot. No, this is bad. What do we call this, guys? What do we call the data type that we use? Like the variable type. Type. I like all these less than async just overlaps the env and inference compute with the training compute at the cost of being one epoch stale. You can read about it in CleanBA. If you just Google cost is CleanBA, they're very nice. I mean, that's exactly where I got it from. It's nothing new. Let's see how much cleaner this is. I mean, everything is going to be much shorter. Like, look. You see immediately this will be a 2-liner instead of a 3-liner. This is going to be a 2-liner instead of a... Oops. That's weird that we have this like that, but whatever. This is a 2-liner. Like, you see? This is why I wanted to do this now. We could do V float. Hello, welcome. Still accepting M's? We're definitely accepting N's. Whether or not they should go to 4 or 5, like, is kind of whatever. It's easier if you just PR them to 5C, but, you know, not big deal. Terra Nova... I don't know what that is. Okay. Mini grid. You definitely don't want to use the mini grid from Farama along with Puffer, because that end will be like 1/100th of the speed that Puffer can have if you're lucky. That would just be like a quick port whatever tasks you care about type thing. Like, I hate to tell people to vibe code stuff, but like that env is so simple that you could get that thing like bitwise equivalent in probably 20 minutes out of any model. But most of those tasks just would get like Puffer will kind of just steamroll most of those anyways. Just like there won't be a research thing to do. It'll just sort of be solved out of the box, you know? Terra Nova paper. Let me see what this is. Oh, wait, I think I know it. Let me see if I think I know what this thing is. If it's the new thing that I'm thinking of, it's dumb. Oh no, this is just not what I'm thinking of. Okay, that's actually fucking cool. What the hell is this? Hey, neural MMO. Wrong. This is actually, cooperation is strategically dominant. This is not a good thing, dude. This is also, like, not... Oh, this is not a good thing. Like, ugh. I hate academic papers so fucking much sometimes. And it's probably cool. So when they say the action space is big, is it like big in the sense of like, yeah, this is reasonable, or just like, yeah, this is a massive pain in the ass for no reason? This is like mini Civ, right? Oh, it's Jax. Is it Jax? Wait, is it Jax? Hang on. Yeah, ugh, God. This whole Jax thing needs to just die. I'm guessing it's vibe coded Jax as well, right? Where's the code for this thing? Oops. Can you go figure out if it's anything and if it's vibe like we already have one major project attempting to port CraftX to Jax. So if it's like an actually good and interesting env, then sure. I'm just so sick of dealing with Jax. Like the amount of brain damage that that entire view of computing has caused is nuts to me. And then of course Jax is hard, so people just start vibe coding it. Ugh. So the annoying thing, to be clear, about having to port Jax to C is you don't just do a one-to-one port, because Jax forces you to write awful, awful code. You have to redesign quite a bit of stuff to get it into nice, efficient C. And it ultimately ends up being simpler than the Jax, but it's just a bit of a pain. Okay, this is definitely not worth Clang formatting. This is not vibe coding. Singer, and I find it. You're encoding. Wait. Yeah. Any. I'm not quite sure how to interpret that question. I am a researcher and I stream like engineering on our latest projects, algorithmic research, various different types of development. Okay, this is like nice potentially. Yeah, we're gonna be able to delete just like a lot of the random new line continues. Can you split? Can you multi-line a kernel launch? Well, I think we're just gonna end up renaming that anyways. Okay. One-lining everything. Okay, that's good. I'm just cleaning up little bits of things here and there. I'd already gone through, to be clear, I'd already gone through this morning. And then I just figured, okay, I may as well do some of the renames sooner rather than later. Because otherwise I'm going to spend time cleaning up the call signatures, and then the width of everything is going to shift a whole bunch. Right, like this. This one can stay. This I'm fine with, maybe? Or like this. I think that's still pretty clear. Okay, I see. This, like, this restrict... It's just the CUDA types being annoying. Just the CUDA types being annoying, realistically. That's still fine, though. Yeah, that's still fine. We'll fix the rest of the SIGs. And then we'll go back up to around there-ish. Well, actually, I think that it is time to go from the, like... Yeah, let's go from here. So I've gone over this decoder stuff quite a bit. Except for, like, occasionally LLM slipping bullshit like that through. I think I'm generally pretty happy with this code. I'm generally pretty happy with this code. It's quite a lot, but it's actually fairly simple. It's actually very simple if you look at it. Okay, so... Do we need both add kernels here? Okay, good. This is done. Still have the async stuff to look at, but policy looks much better. And then basically this gets us down to muon, which, barring any major improvements to the structure of our networks, I think is good. AI assisted, no idea what good jacks. That's the thing, there isn't good jacks. Um, it's like a fundamentally stupid programming paradigm. Is this... Oh, Edinburgh. Okay. Yeah, they have decent people sometimes. I don't know. If somebody feels like doing a quick seaport of it, by all means. Just like, I mean, it has to actually be something reasonable. If you're gonna like just write one prompt and be like, "Oh, okay, it's done," even though the code sucks, I don't want to deal with that. One moment, I will be right back. I gotta check one thing. All right. Yeah, the problem with Jax is like it's this really weird immutable functional crap paradigm, and that's not how computer works. Particularly not with Sims. Well, yeah, you'll get an ML job at Google. Is that like... I mean, if that's what you, if that's something that is appealing to you, by all means. One of the funny discoveries that you end up making is like none of these big companies have, on average, good people at all. And also being top 2 percentile at Jax, like, so being good at expressing operations in their shitty Python DSL, like, brain damage, my guy. Nobody says, like, oh, get really good at Torch, right? It's such a Google bro thing. Okay, Kinvert, but at least that's, like, an honest, like, motive or whatever. Sure. Cool. Which is exactly, it's just like Google brain damage. Okay, I think this is good up to Muon. Why do we have 3 kernels for this? Let me see. We have so many kernels for Muon. Let me see. Yeah, why do we have so many of these kernels? We're just calling them one after another with arguably the same. Okay, it is a reduction. It's like an annoying reduction pattern, I guess. It's just kind of awkward. Let me see if I like this more. Hey, Tim. So if it's since it's been a while, Puffer 6 and Puffer 5 essentially got switched. So we're doing like full native CUDA C training pipeline plus speed improvements before we're doing algo stuff. Though we did manage to sneak async training in. We have some really fast results, and the code's going to be much more compact and very clean and no Python crap in the middle. Um, but I didn't get to really fully explore the state set stuff I wanted to. I've enjoyed parts of it. Oops. I gotta do one thing on the side here for client. I have to add somebody to a GitHub repo real quick. Hang on, I got a 2FA and shit. Uh, this. Why are... Hang on, let me see. Why are muons being mentioned? No, so muon is also the name of an optimization algorithm. It's a successor, or it's an improvement for the most part over Atom. Okay, it's actually faster, which is expected. Very small win. Still have a lot of kernels. Like scarce partials. Is it really faster to have a, like... See, this is me just not knowing enough CUDA yet. Is it really faster to have a separate... Oh, this might be because we need to do, I think it is. I think you do. I think that is standard. Okay, because it's block reduce. So partials reduce, and then you get the Nesterov. Wait, hang on. Uh, Wait. Partials reduce. How the hell does this algorithm work? Do we still have... Let me remember this. I wrote this a while ago. Okay, so it's pre-norm. And then there are many ways that you can do this up. Fine. But this updates momentum. Wait. So this is norm partials and grad norm. Okay, so we're using this on different stuff. Cool. I have a lot of complexity here. And I'm trying to figure out why. I need to add somebody to a repo, and I can't figure out why it doesn't, like... And I think that's not on us, that we don't have access to the thing, so I can keep going for now. That's just a lot of kernels, man. Okay, I think we'll accept that this is... Well, should we accept that this is fine? I don't know. He's just not trying to atomic add shit. Um, this is just a simple block sum, isn't it? Okay. It's just a big old pile of kernels. How are you? Doing well, thanks. Maybe there's a way to restructure this a little. Add respect for the grind. It's honestly not that big of a grind lately. You know, I have some, there are definitely times where I'm just not putting in as many hours. Just the consistency long term that really matters. Okay, so we go through all the blocks. Hang on, this is update pointer equals scale equals. Can I do this? Wait. Okay, no. So I need to do the weight update needs to get applied unconditionally. And this is just what, like, biases, embeddings. Wait, why am I doing... What am I doing? Wait, am I dumb? Why am I doing... Isn't this misaligned? I swear an LLM screwed this up at some point without me noticing. Hover 5 is coming along very well. Major changes. NetHack is giga-sodaed. The NetHack policy is awesome. Finn is slightly away this week. Finn's interning with us. He's been doing great work. Do not like this, man. How do interns get accepted? In the case of Finn, he submitted me the best PR I've ever received, and then continued iterating on it for several months. And then he asked me for an internship, so I couldn't say no, obviously. And he's been kicking ass as well. Like, look at this. We did this in the first week, just cleaning up the drone env. I mean, it's ridiculous, right? Like, look. Same policy, perfect hover, same policy to a cube, same policy to the American flag, hover, race. Right? So pretty much we don't really take interns unless you do this. And then it's like, yeah, okay. We have to be losing. Hang on, aren't we losing something here? That's not old Arch, that's like yesterday. Oh, I guess a couple days ago at this, yeah. That's in progress. Finn's doing that. Wait, so we have this gram. I'm so confused here. Hang on. We have this gram. Why are we doing this, man? This stuff matters. Okay, we have this gram matrix buffer. Why do we need this? Okay, hang on. There does have to be a buffer because... Does there be? Does there have to be a buffer? Where's my old muon implementation, man? Did I actually do it this way? I guess I must have. This is annoying because I don't trust Grok to be able to do this. Can you do this in place? It's it's like a it's like one minor version behind the other models, but it's way faster. Like the other models feel awful to use because they will just spin for an hour. They like completely take you out of the loop. Okay, so we're bleeding. Um, they have this like fast mode, but it's not for the latest models. What I've seen. Also, they just like it's ludicrously expensive. Whatever. I'll let this spin a second, and I'll figure this out. Let me use the restroom real quick and grab a drink. All right. Let's see. I did already spend quite a bit of time on this path, so it's quite possible that this is better. Okay, you can't do in-place coup blast. Possibly we can get the I have to think about this a second. Need to fuse the Constantine, I guess. Slightly annoying. It does seem silly that I don't have single update though. Like, that should be decent. Mm-hmm. One apply path. Yeah, I think that's what we want. I think that would work. It's just using the buffers such that you end on you end with them in the correct one. Now mind you, can't change this iteration number without breaking it, but that's totally fine. And this is also, it's like a pretty nice setup, honestly. It's funny I almost didn't see this, man. Because there was too much nesting. I almost didn't see that this was messed up. Nice. Good. See what this does. Same purpose before. What's a cleanup? A little cleanup. I mean, that feels better as well to me, having it this way. I was pretty proud that I'd come up with that before. The fact that LM just decided to break it for no reason is bullshit, so... That's good. 1, 2, 3, 4. Uh... uh there's an extra kernel here. Okay, but it replaced a previous one, that's fine. This... Don't need to add more space, we already have curlies. Oh. Just do that for now, it's fine. It's like this... Don't even save any code to remove that feature, it's fine, just leave it. I really wish we could get this changed, but hang on. Offset plus equals NE. Oh, wait, hang on. I think we can. If that works, I'm happy. Yep. I'm actually happy now. 2 for loops. It's funny how happy I get over saving an indent level sometimes. But in my mind, this just is so much easier to follow. Yeah, that's much easier to follow. Okay. I'm genuinely a lot happier with that. I think anything else is pretty minor now. Mm-mm. Might be a way to clean this up, might not. I think that this is pretty good, though. We may or may not care that much about Prio because it's likely that this thing gets deleted in Puffer 6. What exactly use Puffer in real world? 2 or 3 examples. Sure. A few things we've done. This driving sim is used professionally by multiple companies in autonomous driving. This is a collab with NYU. We made their thing 15x faster. We could probably make it another 10x faster with some work if we upgraded it to our latest code. Derivatives of this drone sim have been used professionally, so the details of that are confidential. There are these that I can show. The Archive sim, which is open source, is used in commerce. We've also done work professionally in finance and gaming. On the research side, Puffer is becoming increasingly widely used, and it's multiple orders of magnitude faster than everything else out there. It has led to the development of multiple major algorithmic upgrades to RL, as well as to getting dozens, if not hundreds, of new people into the field, because all of a sudden you can run experiments basically instantly without having to have Google scale compute. Practical project on this channel. I've done several. I mean, I've streamed work on several projects, including 1 or 2 professionally. But, like, the point of this channel is, like, I just do the dev that needs to be done on Puffer Live. I put out educational resources, and some of the stuff I do is educational, but the priority is building the library and doing the research. But right now, for instance, this is me working on improving the code quality and refactoring for the next release, the release of Puffer 5. This is inherently, like, pretty slow work. It is actually very informative if you're looking just for, like, how to write better code overall. And, it's, I'd say, actually one of my more valuable skills. It does require a lot of patience, though. You know, once I'm done with this, we have research on self-play. I streamed some of this a few weeks ago. There was an env that I was working on live with Robocode like a week or 2 ago. Matsai work? Yeah. I really, really do want to get into scientific sim. But in my mind, it's like the field needs to be, if not solved, at least consistent, stable, and mature. We're very close to that. It's within the year. Well, not the calendar year. It's less than a year away from now, though. Okay. Make sure this still works. It's nice. We didn't break determinism. That's good. Open review rebuttal is so lame. Welcome to academic publishing. There's a reason I no longer do it. Look at that. Save us a line. A few different little places, probably. This one's fine. Is it? That's cleaner in 4. We'll keep this. Yeah, exactly, Adrian. I really am not a fan of the current direction that scientific research is taken, especially now. I just don't think academia optimizes for the right things anymore. And if you want to do something that actually solves problems, you're kind of better off just focusing on solving the problems than like pleasing reviewers. And I have no idea what you just said. This is just a ton of annoying kernels. I don't know how much I care about this. Hang on. 1354. It's 200 lines of code, man. Plus the Alex. Okay. We've got a norm, we've got a reduce, we've got importance weights. Reduce, normalize, build CDF. It's all open source. There are tons of helpful people in the Discord solving lots of different problems. A lot of hobbyists kind of just learning the ropes. But then there are also several people working on some harder things. CFD. Oh. Yeah, I don't know on that one. Convert. It's powerful tech. Like, there are going to be a lot of things you can solve in Sim. But I'm not going to go around, like, once I start doing that, I'm not going to just go around trying to solve every problem with Puffer, right? I figure that this tech is powerful enough that there are going to be a lot of obvious standout problems once I start looking for them. I'm not really going to get attached to solving, like, any particular problem as much as it's going to be, what stuff in science can we really shift? And if that sounds vague, like, it is, but it doesn't really matter because it's just a big enough upgrade to generic sim tech that obviously it will have applications. The reasoning doesn't really even have to go much deeper than that. Um, it depends, Adrian. When I'm writing code, like when I'm fully writing code by hand, I would say the design usually doesn't change that much from my original. That's because my designs tend to be very simple and they're kind of efficient by default. Like everything static memory, obfsc type set up to be as small as they can, caching things that obviously should be cached. When I have to, with all this LLM screwballness, though, like, with all the LLM screwiness, I end up doing it in passes. Because I end up porting some stuff with LLMs, but then also I receive so many patches from contributors that introduce LLM written jank. So, like, for this 5C refactor, I had to take a while to even get, like, the code into the files that they, like, each piece of code should live in what files, and get the file structure set up reasonably. That took a while. And then I had to, like, delete a bunch of stuff that obviously shouldn't even exist. And then I had to move around. Then from there, it became clear after that, without all the garbage in the way, that a few things were in the wrong spot. And then you have to go through and get, like, semi-automated, cut a bunch of fluff and compactify some stuff. And there are a bunch of, like, easy refactor techniques for that. And then it becomes obvious that stuff is still in the wrong spot. And, you know, maybe after 5 passes, you get to where I am now, where I can actually go line by line. And still sometimes there are, like, 100-line chunks that need bigger changes. But I'm at least going through, for the most part, line by line and cleaning stuff up. It's really obnoxious. Hello, Jess. We are cleaning up the puffer. Minus 16 lines. Small speed up. Very nice. Yeah, this is better. For reduction. Have it normalized. Got sample. And again, I don't care too much. I don't care too much about this. Because this might just get removed. I'd say there's some very minor speed increases, Jess. But mostly it's shortening code and moving stuff around. Like, there's nothing that has made a noticeable difference in the overall train time, even though you get, like, very small improvements in kernel profiles. More distractions. I mean, the advice that I give to new people, if you read some of my articles on X, my advice for programming an ML article is very good, as is the RL article. Like, my, like, how to get into RL. It's pretty much just learning your fundamentals, gaining practical experience, and not getting distracted by all the noise all around. Welcome, Freedom. Oops. Okay. So assuming I don't care too much about this, like this chunk here, because this is probably just going away in Puffer 6. This is a decent chance, at least. This is a big to-do item. Okay, I think this is where we go. This needs to come from the end. We gotta figure out why we can't do this. 'Cause this is just bad. Not that I'm aware of, Adrian. Please be sure you do not link me a shitty LLM algorithm. Good thing, and it's confusing. I know, being in well, learning at this time, but it's really the case that like there are certain fundamentals you need. Learning those will make things easier. Don't get distracted by people telling you you don't need fundamentals. Those people are dumb. Single rollout asynchronous. That's already sketchy. This doesn't matter at all. Like LLMR, this is just like LLMRL for the purposes of doing non-LMRL is effectively crap. Double side token clip strategy. That maybe, hang on. I highly doubt this is anything, but The fuck? Yeah, that doesn't make any sense. Okay, I guess this one is interesting. Yeah, you can't do this. And it doesn't matter in our case anyways, right? That thing is somewhat interesting, I guess. I will try that one thing. But the rest of this, like, you just, like I said, you just linked me a random LLM algorithm. Build us a live demo on Colab. Oh, Colab? You mean where you run Python demos? This is pure coup to see. You can literally just download this thing and run it locally and train models on your laptop. Okay. Oh, the RL paper? I mean, that's also ridiculous, though, right? Like, how am I supposed to implement you a live demo, like, fine-tuning a big LLM on a Colab GPU? Or post-training, whatever the word is these days. Which is still training. Omni reset with checkers. Okay. That's nice, Jess. I mean, it's nice in the sense that it's like, it's a really basic reset thing that you can do, so probably you can do better if it does anything. Oh, yeah, I forgot that the collab has the premium thingies. The premium, like, whatevers. You know, I don't do LLMRL, though, right? Like, we kind of do everything except LMRL. Our whole stack is completely different, right? Like, Puffer is very heavily optimized for small models. We're able to get up to 10,000x the performance of stuff like SB3 out of the box with Puffer. End-to-end Q2C, custom architecture, heavy kernel fusion, stable bfloat 16, many other optimizations. I'm gonna delete this thing. Write the code. Well, I mean, obviously they are running their own algorithms. They have experiments included. Whether the code is any good is a different story. Okay. Is this worse? It is a little weird, isn't it? Maybe not. We do know this is a slightly unstable. Will 5C expose overall logged values to EMS natively? What do you mean by that? Something you train 50 million on very limited hardware. Okay, so 50 million parameters is bigger than the biggest net that we typically will train in Puffer. Like a big net in our case is something like 12 mil parameters. Like we actually will solve problems professionally, routinely under 1 mil parameters. If you want to see like the scale of what we're doing, as to give you sort of a yardstick, we will very often train on like over a petabyte of simulated data. So our models are tiny, but we literally have more data than the foundation, or the frontier labs for what we do. Perf is over a certain percent. Oh. You could do that convert. It's kind of it would be kind of gross. I don't think we're gonna really be wanting to do a ton of manual curriculum stuff, though. We want to kind of, like, automate it. Petabyte of simulated data. So, I mean, you build a simulator for the problem that you're trying to solve. You train a very small model directly through interaction with that simulator. We can train on up to, like, 1 trillion interactions on one machine. You get a kilobyte per interaction. Kilobyte times a terabyte, you get a petabyte. Yeah, so you don't just, like, obviously you can't build a simulator of everything possible, right? But the point is that there are a very wide range of problems for which you can build a fast simulator. And a number of those, like, Puffer kind of just crushes because of this level of data scale. Obvious applications in control, robotics, games. We've done stuff in finance and commerce. Longer term, I'm very interested in applying this to scientific sim. Scientific sim tends to be less interpretable, though. So we're really trying to make sure that we have very good, stable performance across more interpretable domains first, which should be within the next year or so. Yeah, so longer term, yes, my goal is to get this into scientific simulation. It's not going to be every single sim, but it will be a wide variety of different sims. That is probably what I will be doing once we have Stable, consistent training on game ends. Okay, I'm not gonna bother futzing with this because Finn is just actively messing with this. So sure, he can add 50 lines of code that are annoying for a while. Does this need to be here, actually? Can I just, like, move this up? Yeah, I can move this up, right? Run an agent in a loop. I mean, you can burn money if you want. But, I mean, we can train our agents for, like, pennies most of the time and dollars for the bigger runs. And just is right. You kind of just got to do low-level dev around here. Okay, I have lost complete. I don't even know what the hell this conversation is. Sure, whatever. Load. Okay, this does get reused. Why we have this? Yeah, this is big. Ugh. Giant PPO block. We'll give this the initial pass and then I'll start looking. Oh, there's no pep if you don't have any Python. see. Yeah. Mhm. I literally did that, Jess, in, that was one of the cuts. The point is if you're only ever gonna free something when the program ends, then you don't need to free it. But assuming that even makes any sense, um, that how is that an RL problem? So RL problems occur when you have some sort of interaction in like a multi-step process where the interactions are sort of fiddly and unintuitive, and there's an objective that you want to obtain or maximize by virtue of interaction. Device force. Oh, these. I don't even know if we need these, man. I need to do a larger numerical study on this. But hey, Elliot, we're kind of just cleaning up a whole bunch of crap at the moment. We're making very small little perf improvements at the same time, but it's mostly just cleaning up a bunch of crap. It's a lot of like, why was this like so long again? Oh, okay. Because it's half redundancy. Cool. Let's fix that. Partials. Okay, so this is reusing the sampling logic, which we should be doing. Why are you running on Windows instead of Linux? I'm not. This is SSH'd into a Linux box, my guy. This is just an old desktop that still had Windows on it. See the penguin? So this does have a local GPU, so I can actually run demos in Linux through WSL. So that immediately is better than having a MacBook. Those things are basically paperweights. And I do have a Linux machine at my main office set up. I'm in California for the summer, and I do not have like a nice new machine here. This is just my old desktop that I happen to still have here. Works fine. I'm SSH'd into my 5090 machine anyways all the time. Yeah, but working off of a laptop as like your main setup, that's miserable. That's absolutely miserable. I used Mac OS for a few years and I hate it. Relatively recently, I had to use one for the summer as well, and I hated it. Like, I don't know why, like, I'd way rather just have a desktop. Does Joseph read YouTube chat? Yes. Or I allocated a box to Finn. I don't know if it was that one. I also know a few of the machines died. Fucking Intel, I swear. Never buying another Intel chip. Okay, let's see what we have here. That doesn't help, my guy. Okay. That's actually a nice... That's actually kind of nice. I have no idea what the hell's going on in the chat, but whatever. First of all, optimal strategy Oracle. Um, you should probably just use it for logging, like perf versus optimal, you know? You realize that we already have Puffer in Python, and like there is a version of like literally the current public version 4.0 is a mix of CUDA with some C++ and a lot of C and Python. Like all you're gonna end up is getting something that's much slower and longer than what we have now. Okay. Also used once. Learn, discover, compute primitives. Uh, yeah. Mm, is there... If you can model that as an interactive process where you can iteratively refine a solution or something, then maybe. I I don't know enough about that area to know if there's a reasonable way to set that up as a like an interactive optimization problem. These are cool. We actually do probably need to play around with off-pol correction again because of async. We shall see. What's this caching thing, man? This extra caching thing is jank. If it's gonna cache, it's fine, man, but why is it gonna create a path that's a cache path and a path that's not a cache path just fucking randomly without testing? Like, still add lots of little stupid paths is the problem. What are we doing? Alright. We'll let it spin for a little bit. We probably won't have any anytime soon either, so it's fine. That's sketchy. Second read first. Yeah, that's kind of what I figured. That's funny. I believe this dude. Yeah. The thing that's annoying is Twitter's unfortunately also where, like, if you just, like, every time you see, if you just, like, do this, not interested, like, you will eventually get some cool stuff. There's, like, cool algo work. See, this is very cool as well. See, this is a distillation, though. Hmm. This is still nice, though, because, like, this is actually, I can see I can copy this, and I can stick this in the chat for Jess. This is one of the ends that we do care about. Hmm. Large NT. What's up, Jess? Oh. Yeah. It's not 1 power of 2. The fuck? Okay. This is slightly faster in realistic ranges. It just does dumb stuff, man. It's like I give it the precise ranges to check for tests, and it just like picks some dumbass range. Yeah, I know, Jess, but it gives us a lower bound on how many weights you physically would need to represent the policy. Very likely you can't get those weights without training bigger, but it's still interesting. Like, it probably has the architecture and stuff as well. Welcome, Sonny. Mm, okay, that's different. We do have this in here. I mean, this is the big path right here, right? But in some sense, do we need this? Okay, that's annoying. Yeah, it's annoying. I don't know if there's like a multiple thing, power of two thing here. Um, Compact, sure. Let me use the restroom real quick. I'll be right back. Uh, Actually, I'll just wait a second. We'll do a couple more things and then I'll take a quick break. Yeah. Okay, so it's fine. Just don't like how we immediately end up in Indentland. Can't you? Okay, maybe not. Residual CNN? Yeah. Thought so. There's a dead branch there. Yeah, Jess. It's mostly, just need to go through, like, in a very disciplined way and compare flops and mem bandwidth and such of the operations. I guess that's actually whatever. Wonders on that front not having background. Ooh. Um, that one's tough, Jess. I actually don't think a background in ML would particularly help with that as much as the systems does. It's mostly just like comparing the flops and the memory bandwidth of a conv operation to a linear layer with the same number of params, and then figuring out why the heck these things are so slow but are still giving like good bang for your buck on representational capacity. Like presumably there are a bunch of other things that we could do. It's very difficult because the inductive bias is hard to beat from the conv. There really should be a way to do it though. I mean, beat a conv like globally is a very hard thing. Obviously, I'm not gonna trust this thing. I'm just seeing if there's anything that's free. It already looks better. Love to get rid of this. This looks better. Yeah, it's fine. I'll be right back. I'm gonna use the restroom real quick. All right. Man, there's a lot of code. We're actually almost all the way through algo though, which is nice. I'm feeling better about it. Arcs, kernel arcs. Yeah, okay. How long have I been live? So, I've been live for 3.5 hours. Man, I'm like losing. I'm losing the endurance here. I know I should be able to do a 6, 8, whatever hour session. I guess I am limiting myself to one coffee. So, kind of, Jess. I just really burnt myself on 4. And that was a lot of work. I was pushing that well beyond the point at which I needed to take a break. I'm just trying to be very careful about perf here as I'm cutting little things. Yeah, all this vec load crap. Ugh. think I probably have about another hour, hour and a half on this file. I mean, it's definitely improved. I can check, Jess, yeah. So this is like an undergrad. So the scary thing is like it's like I could have written this in high school almost. Like the language is very familiar to me in some way. The fuck? Huh? Okay. Can you do that? I think you can only do that with 1x1 convs. Seven. I can't tell what he's doing with the receptive field sizes. This this set of ops seems very weird to me. I'm not familiar with like more modern conv architectures. I can't tell if it's relying heavily on one by ones or not. If you can actually do that block fusion operation in a set of architectures that are useful, sure. I think that you're pretty limited in the types of comms you can do that over, though. So, I honestly, I can't tell, Jess. Yeah. No, I mean, it's cool. I don't know if it's like... I mean, the one good thing is this is from... This is from May of 2024. And it has some demonstration of actual knowledge of past stuff. I don't know who this guy is. Yeah. I would take a look. See if you can figure out with GPT or whatever else, figure out what the heck block structure this is actually getting applied to, and whether it's like restricting heavily the architecture you can use, and whether the restricted subset makes any sense. Because I know you can't do that depth fusion on everything. If it turns out that we can do it on the subset of architectures we need, then great. Backward pass might be sketch. Mm-hmm. I mean, com stuff's important. Architecture stuff's just really... Like, there's a lot more that can be done longer term, Jess. I don't think that, small nets are just not designed well for the like modern hardware architecture. It's a tough problem though. It's worth it. Right, but I don't understand the architecture limitation of like, is it all one by one cons? Uh-oh. He lost purse somewhere. I mean, the funny thing is you don't even like, you can literally just download, you can just download Puffer 4 and it's already like that. Like, that's not remotely optimized, but still is ridiculous. H100s are actually slower than 5090s for this type of work I'm doing here. I'll let this figure out the regression real quick. It'd be a nice patch if we can get it to be perf matched. You can get 5090s very easily off of Vast. Hang on a second here. All right. The thing is, John, there are many ways to lie in academic papers. Some of the most lyingest of papers are perfectly replicable. Hey, Coulter. That's not great. Don't have very much left, though. I can definitely finish this before 6. Hmm. Ugh. Pain in the ass, man. No, actually, we got the Puffer AI domain pretty cheap. Nobody had it. I was like looking around for like, what do I do with the company? And it's like, Puffer. Let's see, can I get the domain? Oh yeah, perfect, yay. And then there's some domain squatter bastards that keep trying to sell me the .io for like 15 grand. And I'm like, no, fuck you. I got it for like 99 or something. Wait, are we on BSum 2 again? God damn it. Hello, welcome. This is not Grok not understanding. This is me not understanding what the hell. Fully solve. Oh yeah, we have sub-second breakout now. This is bad. Oh yeah. Do star the puffer, folks. It does help me out a lot. Maybe not. Yeah, I know. GitHub broke a whole bunch of stuff recently. I think just the icon is broken, not the link, though. They broke our star chart. I don't know if you saw this. So we used to have this star chart here. They broke that. It's really annoying. Yeah, so this link is still fine. Breaking star chart's a pain in the ass. I'm gonna have to fix that at some point. SIMD post? No. A R compact that saves 3x the calls. I'm in group Muon. Are you sure you have a compact Muon? I don't... You can't really save 3x calls. I did make one major improvement to Muon earlier, though. I mean, you should know SIMD as a concept, yes. Particularly if you're touching GPU anything. The funny thing is, like, you can kind of just write brain dead, like, 70s, or, well, really, like, you can write brain dead C99 and be 1000x faster than basically all modern software. So, I don't know. Is this really better? Like, I think that this might be, yeah, this might kind of be troll. Hmm. No, it was bad to begin with. This we can definitely improve. Oh, and we did end up shorter. That's same perf as before. Huh? Okay. This is nice. Oh. The hell are we? Is the C++? Why? Oh, this is just the... Whatever, man. I just have to set up a... I need to take the time to set up, better benchmark on stuff. So you don't spend more time launching it than running it because the whole bloody thing is coup de graphed. So if you're timing launch overheads without graphing, those aren't real numbers. If you're timing, if you're looking though at like memory pressure from extra launches, then yes. What are we doing here? Okay. That's super obnoxious, right? Memrites? Okay, then maybe. What part did you batch, though? Did you batch the Newton Shoals, or like... The problem that like the thing that makes it difficult, right, is that you have matmos in the hot path. Mm-mm. That seems bad. Oh. I still don't know what you did though exactly. Batch norm fused. The block map mall. But that wasn't the bottleneck even at like Muon is still a very small slice of training, or should be. Unless I'm timing wrong. I could be timing the Muon map moles wrong. I think you have to split out the map moles in Muon from the map moles and the rest of everything. This is longer. Much longer. Blech. I mean, this is... No, this is bad. This is bad. Let's see what else we can do. That's shitty. Oh, that's super shitty. Man, I hate this kernel. I really hate this kernel. Yeah, okay. Fucking inlined in, like, strings, my ass. Wait, what? That's weird. That's cool. Oops, what are we doing? Yeah, so this is what we want it to look like. It's very simple, but it's kind of slow. I'm honestly kind of kind of surprised that we just don't get this from the compiler. Isn't that weird actually? Why don't we get this from the compiler? Not happy with this shit. Yeah, I don't have enough experience with vectorization on this. I see what it's doing, I just don't know if there's like a alternative way to do this that doesn't suck. One load and one store. Oh. 256. They don't have the token speeds. This is not a great blog from them. Don't have the speeds. Really? Wait, huh? Oh, wait. Okay. 1900 lines. Few things at the end that were a little bit iffy. Still some improvements. Yep. All right. We are net negative here on lines, and that includes me adding additional space. I doubt that there were any meaningful perf changes, frankly. But we did clean up quite a few meaningful things. So I would say that that is yes, I do have a YouTube. Just Here it is. At Neural MMO. And I'm committing this on this side. Okay. 20 nanoseconds per layer, yeah. Okay, star. 1900 lines. 600 lines. 4.5, 4.6K total. If I had to ship this today, I'd be like okay with it. I'll probably make a couple small additional changes, but I think overall, code quality much better today. Much better. All right, cool. I'm gonna call it here, folks. I gotta get some food. What was this? This ended up being a 5-hour optimization stream or 5-hour refactor stream. That's not bad. I mean, if we consider, I'm gonna consider that's like 90% done with the algo file, though. I've already put quite a bit of time into Pufferel, so presumably a stream or two on that. And there's not that much else that's difficult that I need to play with, so this is a good chunk of work. This is like a double-digit fraction of the remaining work done today, I would say, for the release. For everybody tuning in, if you're new around here, I stream all sorts of research, engineering, and so on and so forth. Sometimes it's slow, sometimes it's quick, sometimes it's educational, sometimes it's research breakthroughs. You can check out all my stuff on puffer.ai, start the GitHub, it's all open source. Download it, train some models in a ridiculously short amount of time at home. Join Discord if you want to get involved. And follow me on X for more RL content. Oh yeah, Constellation's super pretty. You can play with all our experiment data here.